Okay, now that we understand where we're going, and yes, we are going to have to implement a controller method. That is the first place that external user input touches our code. So yeah, that's what we're going to code next. And this gives us an opportunity to sort of do the cycle that so far has been provided for you in the homeworks, which is the red-green refactor cycle. So here's the basic approach. We're going to think about one thing the code should do. In fact, in the last little segment there, we just came up with 3 things the code should do. We're going to capture that thought in a test, which fails because we have no code. And then we're going to write the simplest thing we can think of in the code that makes that test pass. And before continuing on to the next behavior, we'll just see whether there's any opportunity to sort of clean up or refactor or beautify the code that we already wrote. And we're going to have a lot to say about refactoring later on in the course, but it's kind of like it's always refactoring time, right? You should never miss an opportunity to do a little bit of code cleanup. So the cycle is called red-green refactor because you go from red, which is failing, to green, which is passing, to refactoring, which is still passing but with an improved code structure. And you keep doing that sort of until the code passes all the tests that you had thought of. So your goal is to always have working code. Whenever you write a new test, it's going to fail. That's like an unstable situation that you want to get away from. You want to get back to green. So that's why the simplest possible code that makes it pass, that's the path of least resistance, right? You have a separate opportunity to beautify or refactor the code, but the most important thing is don't get too far away from stuff that works. If it's not broke, don't fix it. So the question is, if we're going to start doing unit level testing, we have to test things in isolation, right? We've said that there's this spectrum of testing from testing one method or one class at a time all the way up to the integration tests, which exercise big chunks of the app, many code paths. So the basic question we're going to look at next is, how do you test something in isolation, given that sort of any non-trivial piece of code has dependencies on other things that would affect how you would test it? And so the powerful tool that we're going to use here is the code you wish you had. Or maybe it's the code we wish we had. I don't know. But we already said, what should the controller method do that receives the search form? Well, let's just start with our own answer to that question was, it should call a method that will search TMDB for the specified movie. Now, we have no clue under the sun of what that method is going to look like. In fact, all we really know about that method, based on the last self-check question, is that that method is actually going to live in the model. So really, the only thing the controller has to do is kind of pass the buck to the model, right? We have to make sure that whatever user data comes from the app, that's what's going to arrive in the controller. So somehow that data has to successfully get to whatever method in the model is going to do the actual work, right? I think we're in agreement about that after the last question. So the question is, how do we test this controller method if we've already admitted to ourselves that it depends on this other code in the model, which we haven't even thought about yet? So this is where the powerful idea of the code we wish we had comes in. Let's remember we have to add a route to config routes.rb. That's not a problem. We can do a simple route that just posts a form to the search TMDB URI, not a problem there. We already know that because of convention over configuration, Rails will map that, and it will look for an action called search TMDB in our movies controller. That's all well and good. Again, we get that kind of for free. Well, the view has to have something to render, so for now, we'll just create an empty view. That's perfectly legal, not useful, but it will allow our test to pass. So we just create an empty HAML file that has the correct name and is in the correct place, right? This is all just scaffolding so that the world doesn't blow up when we start doing our test. And now we're going to get to the action. We're going to look at that hardwired fake method that Dave used in his example, and we're going to replace it with an empty method. Okay, so now we're pulling out the safety net. The method is now officially going to have to fail. Since I just said we've agreed that the controller has to hand off some data to the model, and the model is going to have a method that does the actual work. But what method is? I mean, we haven't written that method yet. So how could we possibly test the controller action if the thing that it's supposed to call doesn't exist yet? This is the magic part, okay? So the way we resolve this is we'll say, no problem. Let's develop an idea for the code we wish we had. In other words, we know that code doesn't exist, but suppose it did exist. How would we like it to work? And we will use a seam. A seam is a really important concept, and it's basically a place where we can change the behavior of our app without changing source code. We're going to come back to this and talk separately about it. But we're going to insert a seam that allows us to test the code we wish we had, even though that code isn't there yet. So here's the code that I would say we wish we had. We know that it's going to be a class method of movie. So I postulate that it'd be nice if we had a method called find in TMDB, that it's a class method of movie, and that it can take some arguments representing the movie that it's going to try to look up in the TMDB database. So here's our game plan. We're going to simulate in our test what happens when the user posts that search form. We're going to check that when the controller action gets invoked, it tries to call find in TMDB, and that it correctly includes the data that it pulled out of the submitted form. Now, these are useful things to test, right? We're not testing the find in TMDB function itself. We're not testing that it can talk to the external database. The only thing we're testing is that the controller is doing its job, which is separate from the model doing its job. Okay? So, of course, the test will fail because we just made the controller method be empty. And then we'll backfill the controller method so that it makes the test pass. And we could do all of that without ever actually writing the model method. So how would we do this? So let's walk through. This is our controller spec. And as we've already seen, we have a describe block for the overall class whose behavior we're describing. And then within that describe block, we can nest other describe blocks that are sort of testing different chunks of behavior within that class. So here's our test case that says the controller action should call the model method that performs the actual search, that does the real work. We're saying, first of all, we're going to set up this expectation. The movie class should receive the method call find in TMDB with a particular movie title. Right? So remember I said the game plan is we're going to simulate posting the form with some data, make sure the controller action can correctly get that data and hand it off. Well, here's our simulated post. Post is one of the methods that's included in like the Rails plugins for our spec so that there are convenient ways to simulate things in a model view controller. So post is a method that says, what controller are we testing? It's the movies controller. So to that controller, post this action, and it can look up in the routes.rb what URI is required to simulate that post. And here's what's going to be passed in params. So this is the one place that we have to sort of synthesize something is we have to know what params would look like when the user actually submits that form. And there's many ways you can do that. I showed one example is you can put a debugger statement in your controller method and sort of take a look at the params object and see what the form actually looks like when it arrives. So any of those methods is good, right? So what are we doing here? Our two steps is we're setting up an expectation of something that should happen, and then we're executing some code that should trigger that thing to happen. Right, so why does this work? Here's a self-check. Let's see how far we get without me sort of revealing all the details here of what's going on to test your intuition about what that example is trying to show. So should receive is one of our specs methods. And see if you can use your intuition to answer the following. Which of these statements is false regarding should receive? One statement is should receive provides a stand-in for a real method that doesn't exist yet so that we can do our test. Another statement is even if we did have that real method, should receive would override it for the purposes of our test. A third possibility is should receive could be either issued before or after the code that should trigger the behavior that should receive sets up. Or fourth, that it exploits Ruby's open classes and metaprogramming to create the should receive seam, to create the place where we're going to try to sort of change and spy on the behavior of our application without changing the application's actual source code. So I guarantee that one of these four statements actually is false. It is not a trick question.